All right, so this video we're going to talk about metamorphic rocks. So you can see in the picture we've got a picture of the Grand Tetons that is made of not only metamorphic rock but a little bit of igneous rock as well. But this particular point is made out of the rock gneiss, which is a metamorphic rock. All right, so metamorphism comes from the Greek word meta, which means changed, and morphos, which means shape. So metamorphic rocks are rocks which changed structure, texture, or composition. The origins of metamorphic rock. Most metamorphic changes take place at depths greater than 2 kilometers below the surface of the Earth. Large movements within the crust of the Earth cause additional pressure to be exerted on a rock during metamorphism. This pressure can allow minerals in the rock to align themselves in certain directions. So you can kind of see in the image on the right, you can see the layers, we call those foliations of the rock. So because this pressure kind of minerals will begin to sort of sort themselves out based on their density once they get to be slightly mushy, and they will kind of line up in order of density. So a lot of our metamorphic rocks have these layers to them. All right, so there's two different types of metamorphism. The first one is contact. So contact metamorphism is when nearby magma heats surrounding rock and changes it. So you can see in the diagram on the right at the bottom, you've got a magma chamber, and the magma is heating up the earth, is heating up the rock surrounding it. So it's causing the surrounding rock to indirectly warm up and cause it to be subjected to heat and pressure. So the greatest change takes place when the magma comes in direct contact with the surrounding rock. So if it actually melts the rock around it. So it can either heat it, just warm it if it's not directly hitting the rock. So that's indirectly, but the greatest change is if it actually comes in contact with it. All right, so occurs near igneous intrusions. So a lot of times you'll get a magma chamber that is underground, and it will melt the surrounding rock. So that magma chamber, the rock will harden, and that is an igneous intrusion. So around that igneous intrusion, you will start to metamorphosize the surrounding rock. Hornfels is a group name for a set of contact metamorphic rocks that have been baked and hardened by the heat of intrusive igneous masses and have been rendered massive, hard, splintery, and in some cases exceedingly tough and durable. So you can look at the picture up at the top right. That is a sample of banded hornfels formed from contact metamorphism of sandstone and shales by a granite intrusion. So the actual igneous rock, the granite, was cooled rock from magma, so that rock surrounding that magma is getting metamorphosized into a new rock. All right, and the other type of rock is regional metamorphism. So this is more of what we've been talking about. Occurs when pressure builds up in rock that is buried deep below other rock formations, or when large pieces of Earth's crust collide with one another. So the increased pressure and temperature causes rock to become deformed and chemically changed. Regional metamorphism usually produces gneiss and schist-like foliated rock. So you can see you've got the banded rocks up on the top right and the top right and the bottom right. You can see that there's bands, and that's from intense heat and pressure in the Earth's crust. All right, so composition of metamorphic rock. So metamorphism occurs when temperature and pressure inside the Earth's crust changes. Minerals that were present in the rock when it was formed may not be stable in a new temperature and pressure condition. So that can change the mineral itself. Many minerals only form in these new conditions, and we call those index minerals. Some examples: biotite, mica, chlorite, garnet, and kyanite only form in those intense heat and pressure conditions. So we would call those index minerals. All right, so different textures of metamorphic rock. The first, we classify metamorphic rock in based on their texture. So it's either foliated or non-foliated. So a foliated metamorphic rock contains those bands of mineral grains. The minerals are put under that heat and pressure, and they become lined up. They kind of align themselves. So those are called foliated rock, when you can actually see the foliations. Shale is a sedimentary rock. So if you look at the diagram on the right, the very first rock pictured at the upper right is shale, and that's a sedimentary rock. It's made of layers of clay, so it's got the strata from sedimentary. But when it's exposed to heat and pressure, it becomes the metamorphic rock slate. All right. However, it's not done yet. So if the environment changes and the metamorphic rock is put under more heat and pressure, that slate will then become phyllite. And then, if phyllite is then put under more heat and pressure, it will become schist. And if schist is put under more heat and pressure, it becomes gneiss. So you can kind of see in the diagram on the right the different stages of rock formation. So that shale doesn't just miraculously turn into gneiss. It goes through different types of rocks. So they're going through different stages, becoming the next type. All right, the other texture of metamorphic rock is what we know as non-foliated. So non-foliated metamorphic rock is in which the minerals are not arranged into layers. Commonly, metamorphic rock is made up of only one or a very few types of minerals. So you can see that in the diagrams below, you've got quartz sandstone, which put underneath heat and pressure, um, becomes quartzite, but it's not foliated because it doesn't contain a lot of different minerals that actually line up. You could see that limestone and chalk, both put under heat and pressure, can become marble, and you can see that marble is non-foliated. All right, so there's no distinct layers in marble. All right, that is all I got for you for metamorphic. Let me know if you have questions.